Good morning, everyone, and a warm welcome to the Industry Connect talks here at the ITAP 2021. For this segment of presentations by A-Star and partners, we're very happy to touch on the topic of hyper-personalization, and there'll be two segments to today's session on this hour. First up, we have Mr. Prashant, who is a consultant with ARTC and A-Star, with many years of experience and as a subject matter expert in this area. And let us warmly welcome Mr. Prashant to share his portion in this presentation today. Prashant, please.
Hello and good morning. You able to hear me well? Wonderful. Welcome to ITAP. I'm going to speak to you about my personal views on the next generation hyper-personalization. What I plan to do is to cover this topic by briefly describing the terminology of what customization, personalization, and hyper-personalization is. Followed by this, I will talk about what are the key criteria and what is leading to this rapid absorption or evolution of hyper-personalization. I'll touch upon the current constraints and how the industries are trying to respond to this change. And then I'll finally give you some examples and conclude with telling you what we at the Advanced Remanufacturing and Technology Center are doing to help our clients address this big challenge. Before I commence, I would just like you to pause for a moment and think. The creative forces of nature would have certainly liked or cherished the evolution of uniqueness because it has created such an enormous variety, almost inexplicable amount of variety of unique individuals and things. It is this uniqueness which makes things really invaluable and irreplaceable. And compare this with the concept of industrialization, where you look at commonality among things and try and find solutions for the common problems because you want a certain scale, you want to make it viable. So there lies the contrast, that at one end, there is this uniqueness and this variety at play, while the industry is looking at commonality and looking at saying, how do we evolve and justify the investments in the industry? So since Ford invented the T model car in the 19th century and said you can have any car as long as it is black, the world has moved on. Today, the need for customization, personalization has rapidly grown. So let me clarify some of the terminology which has been used in the industry. Let's begin by understanding a little more of what is customization. So customization is all about where the consumer or the user actually customizes the site or the service provided. Take an example. I get into my family car. As I step into it, I adjust the seat, move it backward or forward, adjust the height, adjust the mirrors, adjust the station that I want to play, maybe BBC News, whatever. That is the process of customization. So I've been provided with a set of options and I choose what works for me. Most weather channels, when you subscribe, they would ask you, which location you want to know about. So that is typically what is called customization. As against that, when you look at personalization, here the system tailors the need based on previous behavior of customers. So say same example, if you look at the new modern cars, for example, the Audi A8, as you sit into the car, as you open with your key, the car identifies who's the driver. It automatically adjusts all the seats, the stations, the mirrors. In fact, the newer cars even adjust the trunk height of how much it should open depending on your height. So that is a classical example of what is personalization. The hyper-personalization is the next level of personalization where you use real-time data, you leverage artificial intelligence. That is going to be my next car, where, for example, as I decide to drive to work, I get a message from my Google Nest to say, time to leave. It's going to take you 25 minutes to drive. As I reach my car, the door opens up, It automatically adjusts the seat's height. It automatically adjusts the mirror. It puts on the GPS. It knows where I'm going. It has asked me to come in 5 minutes earlier because it said you have not had your coffee. You can pick it up along the way. Starbucks is on the way. It's also, it sort of alerts me to saying on your return path, on the road, there's a place where you can charge your vehicle as you have your coffee. So that would be the hyper-personalization where you would leverage the AI and the intelligence in real time to be able to provide me the service that I'm looking for. Let us look at a little more around the importance of personalization. Since the industry evolved, when earlier it was all about classical job work, and that's how it all started, where you had a lot of variety, but the production volume was relatively very small. From there, you moved on to the classical batch production, where you made more of the same, larger batches, where you got some benefit of scale, but again, the amount of varieties you could produce was relatively limited. Then came the classical mass production, where you were looking at scale and hence efficiencies, and that drove the rate of production rapidly. So while, as you see on the chart provided, while the production volume moved up, the value per pack actually started dropping. As against this, when you look at hyper-personalization, which has a far more modular design, and it allows reconfigurable manufacturing system, you can now produce a much larger variety and have a much higher value per pack. So as the industry is rapidly realizing that if you are able to target your segment carefully, the chances of you getting a much higher value for the target segment is much better as compared to, let's say, the scale production. Let me take you through a typical example of what the consumers say about this trend. So 90% of the consumers or 91% of the consumers say that they would like to shop with brands that provide and offers and makes recommendations that are relevant to them as per Accenture. Or if you look at what Statistician has to say, it says 90% of the consumers find marketing personalization very, very appealing. What do the technologists have to say? If you look at what Jeffrey Moore says, that without big data analytics, companies are blind and deaf, wandering around onto the web like deer on a freeway. Google, for example, spends enormous amount of time and effort in making sure that the consumers have a very seamless and a beautiful, intuitive experience across multiple screens. The last one is interesting, where Eric says that 90% of the scientists who ever lived on this earth are actually living now. And he says that because if you see the number of fields that have opened up, the nodal points that have opened up, the sheer number of people who have done their doctorates and who are living right now on this earth are enormous. So think of it, what is likely to happen in terms of technological change and its adoption. Let me take you through a video which shows how this is effectively utilized.
This was just the beginning. Then we asked ourselves, how can we bring relevance and attention to each comparison on social media, real time? The answer? With data and technology. Using an algorithm, we found lookalike photographs on Getty Images. Through Facebook data, we identified travel enthusiasts who are interested in specific destinations. For example, Lucas. Geo-targeting pinpoints Lucas' current location and the airport closest to him. Another algorithm finds the destination airport. This data is sent to a search engine that identifies the cheapest flight price in real time. We then show Lucas how much the cheapest flight costs and make him an unbeatable counteroffer, completely automated in an infinite number of variations, turning a unique visual idea into a real-time social media price comparison that moved Germany.
So this is a classic example of how Deutsche Bahn, which is the Deutsche Railway, engaged social media, large data analytics, geoanalytical work, which was all pulled together to be able to help the railway there realize its potential by bringing out this ad which said, you don't need to fly. There's so much things to see in Germany which are as good as anywhere else. Let's look at some of the factors that are augmenting this growth of hyper-personalization. Look at the social media today and how people are far more willing to share their personal data, their personal uniqueness with the others. This was never there before. In terms of technology trends, there are rapid breakthroughs which continue to happen day in, day out, and technology is today able to address far more challenges than ever before. If you look at the channel play and the explosion of e-commerce, especially what happened during the COVID times, it has been phenomenal. And that is allowing products to be delivered directly to the consumer, nearly at the point of consumption. If you look at mass urban transport, this is also very rapidly changing. I think the further breakthroughs which will occur with the evolution of the electrical vehicles, which will be driverless, and drones coming into play, will dramatically change the scene further. I think it's only a question of time where the new technology of drone, which is able to use multiple sensor devices, which Amazon calls it avoid and track, have become very effective. They use technologies such as Bluetooth sensors. They use QR codes for final locations, and they're becoming very, very effective. Trials are already on the way. It's just a question of time before they get used within the industry. And then there is, of course, the rapid evolving business models where value is being created in the whole supply chain is being relooked at. And there are especially there are better ways of creating value in places where there are new opportunities seen by the businesses or where technology is rapidly evolving. Let me show you another example, which is built in NUS, about how even an ordinary thing like drinking can be made so personalized.
A solution to create your own drink with our virtual cocktail. Virtual Cocktail is an innovative drinking platform which can simulate 3 digital tastes, generate 3 scents and lights. By combining these sensations, Virtual Cocktail can enhance the flavour of an existing drink or overlay flavours on plain water. It can be controlled from your mobile through Bluetooth. Flavour sensations can be customised depending on your preference. The visual simulation gives users a certain expectation of flavours. The electric taste is enabled by a control current which simulates sour, bitter and salty tastes. The aroma is released when users drink to give them a full flavour experience. Without the need for excessive additives, everyone can enjoy any drink that they want. You can also share drink information to each other, recreating drinks digitally.
So even this has become virtual, where you can change the color, the flavor, the aroma, and suit it specifically to your need. Let's talk about another example of Shiseido Optune, which is able now to provide you a very personalized skincare system. It can scan your face and identify what the specific needs are, and out of 80,000 possible combinations, figure out what is the best one that will work for you. Another classic example of personalization. So wherever there is good margins, wherever the brands are not very big and new brands can find a play, wherever the regulatory pressures are not very high, you can see hyper-personalization rapidly growing. So it's already become big in cosmetics, it's growing into clothes, it's growing into leather goods, and now slowly coming into the FMCG space. Of course, even in case of medicines, for example, in nutraceuticals, it seems to be making strides. What are some of the challenges in implementing hyper-personalization in the industry? The first is that if you have brownfield sites where you have mass-scale production, then obviously the change from mass-scale production to hyper-personalization is not an easy one. It is challenging. because it would require a completely different infrastructure. The second is around the losses, that if you kept changing over your plants very often, then there would be yield losses, material wastages. There are challenges of cleaning the plant as you change over from one to the other and so on. And then the added complexity of saying different labels, different track and trace systems for everything to work. So all these are the classical challenges that the industry faces today when it came to implementation of hyper-personalization. So how are they addressing this need? First, they are on the lookout for emerging startups which are successful and see if they can buy out. Just to give you a statistic, Amazon over the last 20 years bought about 128 different companies because they wanted to sort of make sure that the growth continues. Similarly, setting up customization centers to do the customization at the very end of the process so that minimal changes have to be done in the plant and the customization occurs outside is the strategy which they're adopting. So name any large FMCG and you'll find that they've set up customization centers everywhere. Then they are looking at design of new plants that are modular, they are reconfigurable, and hence follow the supply chain 4.0 principles. And then of course, they are moving more and more towards the demand-led approach rather than the supply-led approach. Here is what we at ARTC are doing.
Online shopping
and we could
has
support
become
the
an
industry.
essential part of daily life. In this competitive consumer market saturated by retailers, customization is key, and hyper-personalization is the solution. With our proprietary platform, orders are processed instantaneously through real-time scheduling, and our robust next-generation hyper-personalization line fulfills the orders where each process is tracked with blockchain to ensure utmost integrity of end-to-end transactions throughout the supply chain. Through digital twinning that mirrors the actual production and real-time data analytics, the overall line performance can be optimized and potential issues forecasted before they happen, minimizing downtime and improving both efficiency and optimizing the product. The line allows powder or liquid products to be personalized and mixed in different recipes according to individual preferences, offering an impeccable consumer experience. Textured surfaces of the mixers minimize fouling and waste, reduce cleaning frequency, and increase process yields. Cleaning systems can be activated on demand to ensure adequate cleaning for the next run. Every hyper-personalized product undergoes rigorous screening and testing to assure the highest quality for your customers. Once inspected, our autonomous robots work seamlessly in tandem to consolidate orders from the automated depalletizing line, where cartons of goods are removed from pallet, uncased and efficiently arranged, no matter how fragile your product. A touch of personalization completes the package, bringing timely deliveries with best-in-class services to wow your customers. Ensure your logistics fulfillment and grow your business.
So we at the Advanced Remanufacturing and Technology Center, which is a public-private partnership, have invested $20 million on setting up this hyper-personalization line, a test bed. You're all very welcome to visit it and see how it works. If you have products that you want to explore or want to try out, you're again very welcome to connect up with us. And you can meet subject matter experts in different areas. We have already identified about 13 work tracks that we have developed. Some of them are unique and different. And again, as you understand them and as you test your products, you might be further encouraged to progress on to this process of hyper-personalization. Feel free to connect up with me at any time if you're interested to know more about this. Thank you, and thank you very much.
So thank you, Prashant. For the next segment of the talk, it will be on robotics, AI, and visual analytics for a sustainable future. So there are two speakers. First, Dr. Tao from Simtech, as well as Dr. Ray Yao from NUS, our collaborator. And with that, let me invite Dr. Tao on stage to share more.
Thank you, Royston. Can you hear me? Hi, my name is Perian. I'm from the Advanced Automation Division, Simtech, A-Star. My presentation for today will be on robotics for a sustainable future. My presentation for today will split into three main components. Firstly, I'll do a quick cover on the latest trends in robotics, after which I'll take this opportunity to share with you some of our past as well as ongoing work in robotics, as well as some of our past achievements. And lastly, I'll cover on sustainability, some of the applications in sustainability, as well as the role of robotics in these applications. Robots used to work for us, performing repetitive actions in cages, separate from humans, with no contact with humans and the environment, and unable to react to uncertainties. Slowly, with advancement in robotics, robots are starting to be able to work with us through the use of sensing, as well as intelligence capabilities, that they are able to take in information from the surrounding and react to them, so they are able to perform their work around with us. And with the advancement of legged robotics, research achievements in this area, especially from Boston Dynamics, robots are able to work in a human-centric environment. That is, they are able to overcome obstacles that are previously thought impossible for robots to overcome. Lastly, with new dexterous robots as well as smaller robots, robots are performing their work inside of us. Surgical robots that assist surgeons in performing surgery, as well as concentric tube robots or endoscopic robots that can go through keyholes within our bodies and perform surgical operations. Now I'll take this opportunity to share some of our past work. Robots are essentially comprised of three main elements. Firstly, the physical system, the physical embodiment of the robot that reacts and acts on the real world, as well as the sensing component that takes in information on the environment and providing this data to the intelligence portion in order to react to the changes in the environment and react to uncertainties. And the intelligence portion will pass these commands to the physical system in order to react with the real world. We have past work on adaptive grippers, wire-bound inspection systems, as well as applied AI for robot handling. If you're interested in these areas, you can contact me after that. And then for today's presentation, I'll cover a bit more on our work on modular reconfigurable mobile robots, automated lab sample preparation, as well as automated coning deconing. Coning deconing is an operation that's conducted daily in the container yard. This is a manually intensive operation that involves the removal and insertion of twist lock and cones into the corners of the container every time a single container goes on and off the container ship. This is to secure the containers together so that to prevent it from falling over during the sea voyage. Considering that this has to be done every time for each container, and considering that we are the second busiest port in the world, this is done, it's a very labor intensive operation, and automation is required to help reduce the reliance on manual workers. However, this process is difficult to automate, considering that there's more than different types of twist lock and cones that's currently being used. And you can see from this video here, we have implemented this solution using 4 robot manipulators mounted onto movable platforms, using adaptive grippers as well as 3D sensors to be able to perform this coning deconing operation for a subclass of these 20 different models. We are not able to handle all of them, but we are able, through the use of adaptive grippers, to handle a class of the more commonly used twist locks and cones. Our work on modular reconfigurable mobile robots is inspired by the need from the industry. There are many different types of varied requirements and conditions from the different end users on mobile robot solutions, and customization is normally required. There's no one-size-fits-all solution. Even those off-the-shelf mobile robots that you can purchase, you need to make quite a number of customization before it can be used to meet the different needs of the end users. Sometimes the needs are so varied that you need to actually build a customized mobile robot in order to fulfill the requirements from the end user. However, no matter which approach you take, it is very costly to customize in terms of manpower, in terms of resources, as well as in terms of time. And through this, we have proposed the use of functional building blocks, elements of mobile robots that can be combined together to form different types of mobile robots that meets the different needs of the end user to create task-optimized mobile robots quickly. As you can see from the top right video, we can do this fast reconfiguration using these building blocks and then achieve a customized mobile robot within 30 minutes. And then this example we show here is a C-shaped configuration robot that can encapsulate the payload from our industry partner in order to form a singular autonomous mobile robot quickly. Now I'll touch on some of the projects that we did related to the fight against COVID-19. This is a sample preparation automation where we have developed in order to automate the process of sample preparation for the COVID-19 PCR testing. So these samples, test tubes are collected from the public. They need to be transferred, the liquid needs to be transferred into different vials, as well as to the 96 well plate. And this is normally done by the lab technician wearing full PPE, as well as working with the bio booth. And this is mentally as well as physically exhausting process, as they have to transfer accurate amounts of liquid into the different vials. So in this automation solution, we have created this to automate this sample preparation process. We have managed to increase the output, at the same time reduce the fatigue of the lab technicians, as well as to minimize the exposure of COVID-19 to these lab technicians, which they may come into contact with when they handle these liquid samples. We have deployed multiple systems across many different labs in Singapore. At the same time, we also have created new business opportunities for our industry partners that work with us on this solution. This is another automation solution that we've done in the fight against COVID-19. This is for vaccine extraction automation, where we help the frontline workers, the nurses, that are working on the frontline to push up the vaccination rate in order to enable the new normal. They have to accurately extract the vaccine from the vaccine bottle for every syringe in order to perform the injection. And this is quite an exhausting process for them. And we have created this automation solution in order to increase their output so they can attend to more people coming for vaccination every day, at the same time reduce their fatigue, and to improve engagement between the nurses and those people that are coming in for vaccinations. So the nurses do not have to concentrate on extracting the vaccine into the syringes. Similarly, we have deployed multiple of these units across different vaccination centers in Singapore, and we also created new business opportunities for our industry partner. Now I come to the last part of the presentation, which is on the role of robotics for a sustainable future. Sustainability is becoming a more and more important topic in the world today, and there are new applications related to sustainability. For example, in areas in renewable energy, advanced agriculture and aquaculture, waste recycling, reduction of carbon emissions, the collection of rubbish from the oceans, as well as battery recycling. With these new applications, they're also coming out with new opportunities and challenges for robotics to come in. For example, robots can collaborate with humans in order to minimize the danger to humans in these new applications, in order to reduce the physical demands on humans, to minimize the need for humans to work in unpleasant working environment, as well as to reduce the amount of tedious or repetitive work that humans have to do in this type of new applications. For my talk today, I'll cover on three main applications. Firstly, it's on waste recycling, which is an important aspect of the circular economy in order to keep resources within the economy, as well as to minimize the dependency on the extraction of new resources and to reduce the need for handling of this waste disposal. For my presentation today, I'll focus on the role of robotics in battery recycling, which is becoming more and more important with the electrification of transport, where the demand for batteries, as well as handling of battery waste, will increase. The next area is on agriculture and aquaculture, where food security is an important aspect of a sustainable society, and food security is also a major concern locally. And there's a growing amount of interest with investments and new startups in this area. And today I'll focus on the role of robotics in the automation of some of the processes within agriculture and aquaculture. Lastly, I'll touch on renewable energy. Generation of electrical power is contributing to almost 30% of all carbon emissions by humans worldwide. And there has been recognition of this. There's 134 commitments made in the Paris Agreement to increase the amount of renewable energy sources. And for today's presentation, I'll focus on the role of robotics for offshore wind farms, where there's a growing number of these offshore wind farms. In the robotics for batteries and waste recycling, as mentioned just now, with the surge in with the electrification of transport, there'll be a surge in demand for batteries as well as processing the battery waste. This is a quite sizable market at the $10 billion in 2020, and it's growing at 11% cumulative annual growth rate. And recently, Ford has invested $50 million in the battery recycling startup, as well as opening of a battery recycling center in Tuas. This assembly is a process within this battery recycling, which is manually labor intensive, and it's also dangerous, where there can be fire hazards if batteries are not properly discharged, or humans can come into contact with corrosive elements due to the electrolytes in the leaking batteries. For this, robotics can contribute in this area through the development of adaptive grippers to handle the different types of assembly process required, and also to handle the different types of battery packs. That is just the physical element. The vision and AI is required in order to adapt and to guide the robot to adapt through the different types of disassembly process required on the different battery packs. And finally, also hyperspectral imaging, where we can use it to identify different types of material compositions in order to do the waste sorting, which is not just limited to battery recycling, but also to recycling of different plastic materials as well as general waste. And for robotics in agriculture and aquaculture, as I mentioned just now, this is a major concern locally with the push for 30 by 30. However, there's a lot of labor-intensive processes within this agriculture and aquaculture. For example, the transfer of larvae, feeding, health monitoring, as well as for agriculture, harvesting, packing, and transplanting. Robotics can come in to help this through the use of soft grippers in order to prevent damage to the livestock and produce during the handling process, which, as you can see from my examples here, out of these 6 listed activities, 4 of them involves handling. And our collaborator from NUS, Professor Ray Yao, later will give a talk on soft robotics. And in addition to the physical element, also the vision and AI part will come in order to guide the robot to properly handle and know where to handle the produce and livestock, as well as to do quality control, counting, as well as grading. And lastly, for offshore fish farms, the use of underwater robots to monitor the water conditions, as well as to do counting of the fish stocks. Now come to the last application, which is in offshore renewable energy. As I mentioned just now, this is a shift towards renewable energy worldwide. And offshore wind farms is expected to grow at a 30% cumulative annual growth rate from 2020 to 2025. And in our area, for China alone, the capacity is going to grow from 6.8 gigawatts in 2019 to 50 gigawatts in 2030, 8 times growth within the next decade. And considering that each offshore wind turbine needs 5 maintenance visits a year, and with each offshore wind turbine at 3 megawatt capacity, this will translate to thousands of offshore wind turbines, as well as tens of thousands of visits required every year. And in this conduct of this offshore maintenance, there's one process, which is the transfer of people from the maintenance vessel to the offshore wind turbine. This, as you can see from the video, can be quite dangerous depending on the weather conditions. Robotics can come in to assist in this to reduce danger to humans through the use of offshore drones, where we do not need to transfer humans material from the maintenance vessel to the wind turbine, and just through the use of drones do the inspection. However, there's a challenge in this because there is inclement weather conditions, especially since these areas are likely prone to high winds, so that's why the wind farms are situated there. So we need to be able to have controllable flight and as well to take good quality images for inspection using these drones. As well as the use of AI and vision to guide the drones to different areas to conduct inspection, as well as to take in good quality images even in the presence of changing lighting conditions or in the presence of rain. And lastly, not all operations are just based on inspection. Sometimes there's physical contact that's required that cannot be done by drones. We still need to transfer humans from the maintenance vessel to these offshore wind turbines. And through this, we can use walk-to-work systems, basically, essentially large robots that move and compensate for all the wind and wave actions acting on the vessels, so as to enable safe and stable transfer of people between the maintenance vessel and the wind turbine. And now I've come to the last part, finishing up on my presentation. The robotics capabilities within A-STAR is not just limited to SimTech. We have many other institutes that are also working on different areas of robotics, and they come under the Robotics Horizontal Technology Programmatic Office in A-STAR, combining our capabilities in navigation and perception, soft robotics, adaptive ending factors, reconfigurable mobile robots, system development, as well as simulation, modeling, and optimization. We collaborate with our collaborators from the Institute of Higher Learning, such as NUS, NTU, and NUS, NTU, and SUTD. And our collaborator from NUS, Professor Ray Yao will come up later to talk on soft robots. And we also have collaboration on construction robots and human-robot collaboration. I would like to take this opportunity to acknowledge some of our partners in the technology development, government agencies, and non-profit organizations, as well as partners in the industry, which have contributed one way or another to some of the projects as I've presented in this presentation. Thank you. If you have interest to contact me, this is my QR code containing my contact, as well as my email. Now I'd like to pass the stage to Professor Ray Yao, who will give a presentation on his work. Thank you.
All right, very good afternoon to all. I'm Ray, professor from NUS Engineering. Okay, I'm also the program lead for the Soft and Hybrid Robotics program funded by the National Robotics Program. All right, so why are we doing soft robotics? Okay, essentially this is one area that people are looking at. Okay, in terms of pick and place automation, right? Looking at a growing aging population worldwide. Okay, and of course in Singapore we have a growing manpower constraints, and now with the pandemic we are looking at a very low touch economy, right? So that means we are unlikely to have a lot of human resources being in the workplace to help with this kind of pick and place automation. Okay, but we do all know that robots can run 24/7, okay, and thereby they can increase productivity. So, and of course the downside is with traditional grippers, okay, they are not so versatile, right? They can't grip all possible things under the sun, right? And then they are not as delicate as the human hands. Okay, that's why almost 30% of the pick and place automation that you see in the factories are still being done by humans, right? So we are trying to figure out possible solutions to really mitigate this gap. Okay, that's why talking to industry players, collaborators, okay, we identified there's some automation needs, okay, which is one, delicate object manipulation, okay, and then second, to be able to pick and place items of different shapes, sizes, and stiffness. Okay, so thereby giving rise to this program, okay, called the Soft and Hybrid Robotics Program, where we aim to develop intelligent, reconfigurable hybrid robotics systems for next generation gripping application. And here is where we really integrate actuation, sensing, modeling, and AI to really develop a full system that can do this automated pick and place automation. Okay, for use cases like the vertical farming, food assembly, FMCG packing, okay, as well as healthcare. Right, but today we'll be looking at two main aspects, which is food assembly and FMCG packing. Right, I just want to bring attention to two types of gripper system that we have developed. Okay, one is the gourmet gripper, okay, developed with our fellow colleagues, okay, from NTU, SUTD, as well as A-Star, okay, working also alongside CGH and SETS, okay, to really develop a gripper that can manipulate processed and raw food items, okay, that is less than a kg, and this gripper has a grip width of 3 to 7 cm, so it's actually large enough to cover most food items. Right, as you can see here, we have covered over 50 different types of food items just with one single gripper. Okay, and then you can see, delicate things like the egg can be easily gripped. Okay, fruits like strawberries, cherries, all can be done quite easily, right? As well as vegetables. Okay, the other gripper system that we are developing, of course, alongside with the first speaker, okay, for this session, okay, is the FMCG gripper. Okay, it's a suction-enabled expandable gripper, right? This gripper can actually expand depending on the items that we are going to pick. Okay, so its grip width is from 5 to 30 cm, so it basically can cover quite a number of FMCG items, including a Milo refill pack that's highly deformable, okay, or a shampoo bottle, right, or a pack of cup noodles, for instance. Okay, currently we can pack up to 3 kg. All right, so here, basically, our systems involve two things, right? Apart from the actuation, we're also looking at sensing. Okay, sensing is where we make use of vision, okay, and tactile sensing. Okay, combining this to give us intelligence of how the object looks like, how it feels like, right? And then essentially we can, maybe I need your help to play the video, right? Okay, so within our gripper, we have an embedded vision. Okay, so that vision allows us to recognize, for instance, the Milo bottle. Okay, if it's a Milo bottle, then we use suction, right? So if it's a packet of refillable Milo powder, okay, you use the gripper. So it's quite versatile in that aspect. Okay, can I also have the next video? Thanks. Okay, so here on your right, you see a modeling program that we are working on. Essentially, we are trying to model the gripping action. Okay, why we do that is because we can't pick all the 1 million items out in the food space, right? So a lot of things has to be done virtually. So if we can virtually train the system to learn how to pick all kinds of shapes and sizes, okay, then we transfer the intelligence back to the real world gripper. Right, then a gripper can essentially, by seeing the item, okay, able to grip it successfully in one instance, right? Okay, so that's the digital twin that we are looking at. Okay, just need your help with this video. Yeah, thanks. All right, so as you can see in this video, we develop all kinds of customer grippers, okay, and some of these grippers, as you can see, are very good at packing a range of fast-moving consumer goods, right, as well as food items that we can easily pack into a bento set, and then that can be easily, conveniently delivered to the customers. Right, some additional videos. Okay, I just need your help to click the one on the top left. Okay, this is how we can use it to pick some fruits and different types of fruits. Okay, and possibly vegetables. So this is an area that we are looking at. Maybe the one on the top right. Okay, so working with a local dim sum company, we're trying to pack all these delicate items. Okay, like those Chinese buns. Okay, and siu mai, if you are familiar with that. Okay, we can also pack that quite efficiently without damaging the food items. Okay, bottom left, yeah. Yeah, so here is where we can also customize, packing of interesting or oddly shaped food items that usually we can't pick with a traditional gripper, right? And then the bottom right. Okay, if you're familiar with our local food, okay, Nonya Kueh is one of the very delicate items that we are also looking at. Okay, these are very delicate, food items. Okay, that if you pinch it, it might just burst, and then fluids will just come out. Right. So with the use of this soft gripper, we can actually work alongside human workers, okay, to help to increase productivity, right? And then we do not need to have too many workers working within a confined space. Right, thanks. Right, so looking at the competitive analysis, when we compare our gripper, okay, which we call the Row Plus, okay, it's already a spin-off now, right, comparing against all other companies that are working in a similar space, okay, gripping space, okay, ours has the highest gripping success rate. Okay, almost 20% higher than every of the other grippers. Okay, we did a benchmark on that. Okay, and then of course with the use of a Row Plus gripper, okay, that is likely to reduce operating costs by almost 35%. Yeah. So just want to thank you for your attention. Okay, if you are interested to know more about soft grippers, feel free to contact me. Thanks.